we have discussed about Dobrynyer law of triads and Newland's octaves. Then comes Mendeleev. A scientist named Mendeleev actually arranged elements in the increasing order of their atomic mass, of course, but he has done some background work. What did he do? He actually classified elements. He arranged in rows and columns, okay, and he also arranged them in such a way that each element having similar properties is already placed in the same vertical column. Okay, now there are some good things he has done. Okay, for example, remember these are being arranged in the increasing order of their masses, so he left spaces for those elements of a particular mass which are yet to be found. Okay, however, he also could not justify for the places of noble gases. He did not have places for noble gases helium, neon, argon, krypton, xenon and ranonoctium. So this eventually failed. There is one more reason for the failure of this Mendeleev's periodic table. Okay, that is the knowledge gained by scientists that it is not the atomic mass which should decide the properties of any element. If you have noticed, Dobrynyer, he arranged elements in the increasing order of their masses. Newland arranged elements in the increasing order of their masses, and Mendeleev also arranged elements in the increasing order of masses. Okay, now it is understood that the properties of elements are not because of mass, but it is because of atomic number. Okay, the number of atoms present in an atom, the number of electrons present in an atom, in the outermost shell of an atom. To be more accurate, the valency of the element, the number of electrons in the outermost shell of an element, is actually deciding the physical and chemical properties of the atom. Based on that, we have Moseley's periodic law. Okay, we have Moseley's periodic law, wherein Henry Moseley proposed that physical and chemical properties of an element are periodic functions of its atomic number. Now, based on this, the classification was done, which has undergone several improvements, and finally it is lining up with what we have now, that is modern periodic table or long form of periodic table. Now, I suggest you people to open your textbook and keep the long form of periodic table in front of you. You will notice that the first element, hydrogen, the element below that is sodium, the element below that is potassium. All these are having only one electron in the outermost shell. If you see, we are having periodic table which is more or less like this. Okay, here we have hydrogen, okay, then lithium, then sodium, potassium. Okay, all these elements are having only one electron in the outermost shell, so they all are placed in the first column. Okay, and this column is called group. Okay, now after hydrogen comes helium, and this is an interesting part. Okay, helium. Okay, now hydrogen and helium, which are placed in the same row, are having only one shell. Okay, so we can simply say all elements which are having same number of valence electrons are placed in one vertical column called group, and all elements which are having same number of shells are placed in the same horizontal row called periods. Okay, so in the nutshell, we are having a long form of periodic table which is having 7 periods and 18 groups. Okay, now let me explain, let us simply discuss about that. Okay, I will take the example of a group which you can say like sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Okay, so these are the elements which are there in the third group. Okay, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Now if you notice, all these elements are having only 3 shells. Okay, and that's the reason why they all are placed in the third row. Okay, now sodium, is it a metal or a non-metal? It is definitely a metal. We learned this as a soft metal, if you remember. Then comes magnesium. Undoubtedly it is a metal, and so is aluminium. Okay, similarly chlorine, which is a gas, it is a very strong non-metal, and so is sulfur and phosphorus. So silicon is a semiconductor, transition element, or a metalloid, we can say. Now we see that when we are moving from left to right, the metallic property is decreasing, and non-metallic, it is changing into non-metal. What about this argon? It is a 0 group element or 18th group element, okay, which is nothing but a noble gas. Okay, helium, neon, argon, krypton, xenon, radon, ammonium, all these elements occupy the last column or the last group, which is noble gases. Okay, so this is the explanation about long form of periodic table. Let me repeat once again. Long form of periodic table is having 7 vertical columns, that is, 7 horizontal rows called periods, and 18 vertical columns called groups. So it has 7 periods and 18 groups. Now all elements which are having same number of valence electrons are placed in the same group. Okay, that's the reason why any group you take, it will be having same number of electrons from top to bottom. Okay, and all elements which are having same number of shells will be placed in the same horizontal row. Okay, so also the transition, or what we call this as variation of properties or trends followed in long form of periodic table, we will be discussing in the next class. Now what I strongly suggest you people to do is go through the textbook till here. Okay, try to make a note of what we have discussed, and that note should be having the reason for classification of elements. Please make a note. Reason for classification of elements, Dobrinian law of triads, Newland's octaves, Mendel's periodic law, and Moseley's periodic law. And in Moseley's periodic, after Moseley's periodic law, you will be describing the long form of periodic table. Please make a note. You don't have to draw the periodic table in the notebook. Please don't do that. It is mere waste of time. Okay. In the next class, in the next video, we will be discussing the trends followed by the elements when we are moving along the group or a period. Okay. Until then, have a nice time. Bye bye.